Ever looked up at a storm cloud and felt a little small? Well, get ready to feel absolutely tiny. We're journeying to Jupiter, the king of planets, where storms aren't just big, they're monumental, almost beyond our comprehension. Thanks to NASA's Juno spacecraft, we're peering into the heart of these tempests, and what we've found is rewriting everything we thought we knew about planetary weather. Imagine this, a thunderstorm tower not just a few miles high, but one that stretches up until it's as tall as Mount Everest. That's right, a single storm cloud on Jupiter can reach altitudes of 50 miles, or 80 kilometers, from its base to its peak. These aren't just storms, they are colossal structures of atmospheric power, dwarfing anything we've ever witnessed here on Earth. Juno, with its incredible suite of instruments, has been able to fly closer to Jupiter than any spacecraft before it, giving us an unprecedented front-row seat to this spectacular light and sound show. So, how did Juno spot these giants? It used its microwave radiometer. This instrument is like a superpower, allowing scientists to peer deep beneath Jupiter's colorful cloud tops into the layers where these storms are born. It measures microwave radiation, which tells us about the temperature and composition of the atmosphere at different depths. What it revealed was astonishing. Signatures of ammonia and water, the key ingredients for thunderstorms, being ferried upwards by powerful convective currents. These currents are the engines of the storm, pushing gases high into the atmosphere with incredible force. Think of it like a pot of boiling water. The heat from below causes the water to rise, cool, and then sink again, creating a churning motion. On Jupiter, the pot is the entire planet, and the heat comes from its deep, scorching interior. This internal heat drives massive convection cells that churn up the atmosphere. When you add water and ammonia into this mix, you get the perfect recipe for a superstorm. These powerful updrafts carry ammonia water ice crystals to extreme altitudes, building these Everest-sized towers. But here's where it gets even more fascinating. These storms don't just stay put, they generate other, smaller storms. One of the most intriguing discoveries is something called shallow lightning. On Earth, lightning originates from water clouds. But on Jupiter, Juno has detected lightning flashes high up in the atmosphere at altitudes where liquid water can't exist because it's simply too cold. This was a huge puzzle. The current theory is that the giant primary thunderstorms fling water ice crystals so high that they melt, creating pockets of liquid water where they shouldn't be, leading to these high-altitude lightning flashes. Let's connect this back to something familiar: hail. Here on Earth, strong updrafts in a thunderstorm can carry water droplets high up where they freeze, fall, get coated with more water, and are pushed back up again, growing larger and larger until they become hailstones. On Jupiter, something similar but much more exotic is happening. Scientists now believe that these powerful storms can create something they've nicknamed mushballs. These aren't your typical hailstones. They are slushy, ammonia-rich concoctions, a mixture of 2/3 water and 1/3 ammonia gas. The main updraft of the megastorm is so powerful that it carries water ice crystals far above the water cloud layer. There, they encounter ammonia vapor, which melts the ice and forms this slushy, ammonia water liquid. These mushballs continue to grow, getting heavier and heavier, until they eventually become too heavy for the updraft to support and plunge deep back into Jupiter's atmosphere. This brings us to a major mystery that these storms might finally solve. Where did all the ammonia go? For decades, scientists noticed that Jupiter's upper atmosphere seemed to be missing a lot of its ammonia. It just didn't add up with their models. The mushball theory provides a brilliant explanation. These ammonia-rich hailstones are effectively capturing the ammonia from the upper layers and transporting it, dragging it down deep into the planet's interior, far below where our instruments could previously detect it. It's like a planetary-scale delivery system, cleaning the upper atmosphere of ammonia and hiding it in the depths. This discovery is huge because it addresses a long-standing puzzle and reveals a dynamic, interconnected weather system. These Everest-sized storms are not just isolated events. They are crucial components of Jupiter's atmospheric engine. They act as a bridge, a massive elevator connecting the planet's scorching, mysterious deep interior with its frigid, visible upper atmosphere. They dredge up material from below, process it in a way we never imagined, and then send it plunging back down. This process fundamentally changes how Jupiter's atmosphere circulates and distributes its chemical elements. It's a complex, beautiful, and violent cycle. The energy unleashed is staggering. A single lightning strike on Jupiter can be hundreds of times more powerful than a typical strike on Earth. And these storms can last for months or even years, churning and raging across the gas giant's face. They are responsible for some of the turbulence and swirling patterns we see in the famous belts and zones that band the planet. So, what does this all mean for our understanding of gas giants? It shows us that these planets are far more complex and dynamic than we ever gave them credit for. The processes happening on Jupiter could be common to other gas giants in our solar system, like Saturn, and even to the thousands of giant exoplanets we're discovering around other stars. By understanding the engine that drives Jupiter's weather, we can build better models to understand these distant worlds we may never be able to visit up close. The Juno mission has completely transformed our view of Jupiter. It's revealed a world of incredible violence and beauty, where weather operates on a scale that defies our earthly experience. From shallow lightning to ammonia-rich mushballs and storm towers as tall as our highest mountains, Jupiter continues to surprise and awe us. It reminds us that even in our own cosmic backyard, there are still profound mysteries waiting to be uncovered. These discoveries aren't just about Jupiter. They're about understanding the fundamental physics and chemistry that govern how all planets form and evolve. It's a testament to human curiosity and our relentless drive to explore. Sending a probe millions of miles through space to orbit a hostile, radiation-filled world just to understand its weather might seem abstract, but it's how we piece together the grand story of the universe and our place within it. Each flash of lightning, each towering cloud, is another clue in this epic cosmic detective story. Thank you so much for joining me on this incredible journey to the heart of Jupiter's storms. It's a wild ride, and there's still so much more to learn. If you found this as amazing as I do, please hit that like button, and don't forget to subscribe and turn on notifications so you won't miss our next deep dive into the cosmos. Let me know in the comments what you think is the most mind-blowing fact about Jupiter's weather. Until next time, keep looking up.